what is design for cost? It's it basically a built-in tool for Solid Edge. It includes feature recognizing, which we've had for a few years. This incorporates that, outputs some statistics for your models, sheet metal, and it will actually give you a kind of a basic cost model, which is probably what most people will be using it for, to get the rough estimate, just to kind of get a quick quote out to a customer on a part. All right, so what does it take to make a design for cost file? Well, first off, it has to be able to be flattened geometry using the sheet metal flatten command. All right, so as I mentioned, we had feature recognizer. So I'll show you that how that incorporates into design for cost. And the second part is, again, as I mentioned, it has to be sheet metal. So if you're starting in Solid Edge and you're translating a file, a lot of times people, regardless of whether it's sheet metal part, they'll just say file open part and translate it. Then you can always switch to sheet metal. Well, you can't do that in this aspect. You kind of have to start in sheet metal to make this work. So let me switch over to Solid Edge and kick this off. So I'll show you kind of the basic steps to creating one, how do you use it, and then I'll show you a translated part coming in. So I'm going to use a metric template because basically that's kind of what all the Excel sheet, which I'll show you here, is driven from, metric dimensions. All right, so what is this sheet I'm referring to? So here on our tab right here, we have a design for cost. So it's just another feature in Solid Edge, like feature library or, sensors. It's just a little fly out here. So I'll go ahead and dock it. And of course, we have some values here. And of course, the cost is blank right now. So what Siemens has provided is a little handy sheet, a couple ways to get to it. It's always linked in a binder. So if you know how to get to binder, I just made a little shortcut for it right here to access it. So what they have is a little Excel sheet, and this is the main sheet it works with. Of course, it has your different materials and material thickness and some values. Where these values are coming from, kind of customer dependent. These are just kind of some estimates they put in here. So we have 1020, 5052, 6061, aircraft grade aluminum, expensive stuff, some different stainless, 304, some cold rolled. So how you use this is you can come over here. Of course, this could be 100 tabs. It's whatever material you use as a customer. Put in the list here. Let's say, let's go make this first part out of stainless. So I'll say 304 stainless with some food grade stuff. And of course, we have a list of material thicknesses here. Again, like I mentioned, it's all millimeters. So that's why I started in millimeter template. Let's make it 2 millimeters. And it gives us our values here. All right, so let's go ahead and, copy these. So this is one way to get them in here. And of course, my cost estimate currently is 0 because I have no features. All right, so this works in synchronous or it works in order. It doesn't really matter which environment you're in. So let's create some synchronous, since I'm in synchronous currently, synchronous sheet metal features. There we go. All right, so let's go ahead and give it a value. All right, so as soon as I do that, it's let's go ahead and give it some parameters here, because right now I have no materials assigned. So first off, I want it to correlate with my Excel. So I'm going to say, this is going to be 304 stainless. Again, I made it 2 millimeters thick. So that's going to change some things here. All right, as soon as I do that, we get this little analyze button. Right now it says add a sync. So currently it doesn't understand how much cut. So right now we're looking at a specific cut length of 580. So perimeter, we're looking at 580. So if I add some more features in here, you'll see that number start to increase. Update that, should go up. And so I'm just basically increasing the amount of cut there. So they have basically a quarter for every millimeter of cut. But, again, that's a value that is based on what your machine's going to do. So let's start adding some bends to this. So I'm going to add a couple bends. Let's grab both sides and create a flange here. So we have 1 for flange. So right now our bend quantity is 0. I just added 2, so update that. So now we're looking at bend quantity 2. Maybe we need a louver to be put in there, strengthen these flanges up. So let me just go in and add a couple of, where am I going here? Louvers, not louver, excuse me, gusset. Make that a little bit bigger. That round. Okay. So add that in there. I should make it a little wider, but you get the idea. All right, so I added just another. So for features like that, you can specify certain features that do certain things. You can add holes. Right now, holes are just considered part of the cut. So if you're laser cutting or water jetting, whether it's a hole or, it doesn't really matter. It's just another feature you have to add. So, but if you wanted to split that out for cost justification, maybe you do a post-machining process, and you can add that in there as your own features. So let's pop open where some of this is coming from. So for those who don't know Solid Edge, we have a variable table. Inside that variable table, we have every dimension that takes Solid Edge, all the mass, etc. And we do have our variables listed for cost for our bins, cuts, stamps, etc. We can link to Excel tables. So if you wanted to have a template file that was linked to that, you could technically just come over here and copy one of these for maybe bend, copy that. And of course, for those who know Solid Edge, we can just right click and say paste link. And of course, that's going to link us out to our variable table, to our Excel sheet if we wanted to. I don't want to go ahead and link that because I want to leave that unlinked. But, we can link things together, tie things together. You can make it intelligent. Or you can just kind of do it like I did, copy paste, or have it all template based. All right. And once you're, actually, I'll show you on the next one. So that is using Solid Edge to create your template file. Again, I mentioned we have feature recognizer inside of here, inside of Solid Edge. So let me open up a part. This is an inventor part. I'm going to open again in metric sheet metal. All right. So again, update. Nope, can't do it. Well, first off, we're on a sheet metal template, so we hit one criteria, but there is no sheet metal feature, so it doesn't understand just the part copy right now. So for those who know Solid Edge, we can actually extract some geometry from this. So let's create some flanges and create some tabs. So easy enough to do is thin to sheet metal. So we have a part here. It's got multiple flanges. It's got some complicated tooling to make this particular part, which is an expensive part. But let's go ahead and say this is our tab, and the rest are going to be flanges. So there's going to be several flanges here. So that's kind of the first step to make this work. So I go ahead and hit update. And let's say we're going to make this out of, maybe this goes in aircraft, so let's make it really expensive. They can make it out of 6061. Oops. We'll make it 1 millimeter thick. Oops. 1 millimeter thick and 6061. All right, so let me grab these values. Pop those in there. All right, so there's a couple things missing. Like I don't know if you noticed, mass right now is total 0. So we have to come over here and kind of populate that. Right now it's 0 because I gave it a material. Oh, you know what? I don't think I gave it. No, I did not. Let's go ahead and give it a material, like I said. Go to aluminum, 6061. Oh, actually 2 millimeter sticks. I'm not going to change it. I'm going to leave it at 2 millimeters. I'll just come back and quickly grab it for the 2 millimeter, which was 1.9, but it's close enough. So we'll grab these values now, and we'll pop those out there and replace them. Oops. Update that. So now it's a little 209. All right, let's go ahead and flatten it out and bring this into draft, and I'll show you the last couple things that we can do with this. All right, so there's my flat pattern. All right, so for those who want this data out, you can obviously copy and paste it from here into Excel, or you can actually let me just add a date. We can save this as a CSV, which is, you open up that Excel to see that same data that you just saw there. For those who are familiar with our simulation, we create nice little forms. So this one will let you save a little form out. an HTML format to copy and send to somebody. So here's the estimated cost and all the information, material thickness, and etc. All right, so now let's pop this into drawing. Second, I just click. Oh, sorry, I didn't save it. That's why. Here we go. So now I'm in sheet metal, flat pattern, and scale that down. So under part list, we have a particular field. So under our properties, we actually have that new cost estimate stuff in our list here. So now I can just save that. We have one called cost estimate. Save that. Put that right there. So it gives you the material thickness, the type of bins, and an estimated cost. So that you can get pretty tricky if you want to tie it together and link your variables and do that with the template file. If you want to keep it simple, you just copy paste from the provided Excel.